So now we're going to learn how to solve systems using our third and final method called the elimination method. Some books call this the addition method or the linear combination method. Our book calls it the elimination method. So the steps are to line up all the variables, the constant, and the equal sign. What does that mean? It means that your x's are on top of each other, and then your y's are on top of each other, then the equals are on top of each other, and then the constants are on top of each other. So that's what that first step means. I'm going to go ahead and erase that. I just wanted to make sure you understood because I can't point to it on video. Step 2, decide which variable to eliminate. You're either going to eliminate the x variables or the y variable so that we only have one variable to solve for. Step 3 says multiply the equations to make the coefficients opposite values. So in order for something to add to 0, one needs to be like a positive number and the other one has to be the equal but opposite negative number. And we'll show you how to do that. Then you're going to add the equations together and solve for that remaining variable. Step 5 and 6 are very similar to the last two steps on the substitution method. Once you have one value, just plug it in and solve for the other value, which is the same as we did on substitution. So step 1, make sure all the variables are lined up. And step 1 is done for our first example. The x's are on top of each other, the y's, the equals, and the numbers. Step 1, done. Step 2, decide which variable to eliminate. I am going to suggest that we eliminate the y's. And the reason I want to eliminate the y's is because we have a positive y and we have a negative y. And they are already opposite values, which we need for step 3. So step 3 says multiply the equations to make them opposite values. Well, these are already opposite values. -1 and +1 are already opposites. So I can go directly to step 4 that says add the two equations together. So when I add, I have 1x plus 2x. I'm adding here. 1x plus 2x gets me 3x. -1y plus 1y adds to 0, so they go away and eliminate, which is why this is called the elimination method. The equals comes down, and 4 plus 8 is 12. So when I added it down, I got rid of the y's. Now that was really convenient for us that the positive y and negative y added to 0. But we are going to do some later on where you have to force that convenience to happen. Step 4 says also solve for the remaining variable. So when I divide both sides by 3, this gets me x is equal to 4, and I'm now essentially half done the problem because I have the x variable. I still need to figure out what the y variable is, so I have to plug this into one of the two equations. It doesn't really matter, so I'll use the first one. X minus y equals 4, but instead of x, I'm going to replace x with 4. And then I subtract 4 from both sides, which gets me -y equals 0. Please don't just stop and say, oh, no solution. 0 is a number, okay? A lot of people forget that 0 is a number. Give them a little credit. Now I divide both sides by -1, and 0 divided by -1 is 0. So my answer is 4, 0. If you're interested in checking, you can. Every time you see an x, plug in your x value 4, and every time you see a y, plug in 0. So 4 minus 0 equals 4 in my first equation. That checks out. 4 minus 0 does equal 4. Next, we have 2 times 4 plus 0. Does that equal 8? Well, yeah, 2 times 4 is 8, and 8 plus 0 is 8. So they both check out. Okay, so 4, 0 is our one unique solution. If I were to graph this, it would be two lines that intersect. Okay, I'm not actually going to graph, but that's how the graph would look. Okay. Our next example, we have the x and the negative x all lined up, the y's are lined up, the equals are lined up, the numbers are lined up, and conveniently we have a positive x and its opposite negative x right on top of each other. So I'm going to this time eliminate the x's. And they're already opposite, so I don't need to do step 3 either. So when I add these together, x minus x adds to 0. -y minus y, when I add these, that gets me -2y. 7 plus 3 is 10. Now when I solve for this equation, I can divide both sides by -2 and get y is equal to -5. So in my answer, I have the y answer first this time. Then I have to plug it into one of the two equations at the top. I don't really care which equation you pick. If I do the first one, x minus y equals 7, but what's my y? Negative 5. I put that in parentheses because I have to distribute my negative. Negative times negative is a positive, so this is x plus 5 equals 7. Then to solve for x, I simply subtract 5 from both sides, and that gets me x is equal to 2. So the other part of my ordered pair is 2. If I want, I can check. Again, this is totally optional. If I plug in x is 2 minus a negative 5, does that equal 7? Yes, it does. 2 minus a negative 5 is actually 2 plus 5, which is 7. Negative 2 minus negative 5, is that equal to 3? Negative 2 plus 5 does equal 3, so this one also checks out. So if I were to graph this, that would be two lines and intersect at one unique point at 2 comma negative 5. There is no other solution other than 2 comma negative 5 that works for both equations. Our next example is our first example where the variables aren't already lined up and equal and opposite. So this is the one where you have to do some more steps. But step 1, is everything lined up? X is on top of x's, y is on top of y's, equals on top of equals, and numbers on top of numbers. Yep. Decide which equations do you want to eliminate. Either you can eliminate the variable x or the variable y. In this case, I think the y's might be easier to eliminate because between 1 and 5, the least common multiple between 1 and 5 is 5, whereas the least common multiple between 10 and 3 is 30, so my numbers would have to be a whole lot bigger. So I choose to get the y's to eliminate. That was step 2. Choose which one to eliminate. Step 3. Multiply the equations to make the coefficients opposite values. So do you see that this is already a negative 5? Okay. So what I want is I want this up here to be a positive 5. That's what I'm hoping for because I want them to be equal numbers. So I both want them to be 5. And I want them to be opposite. So if the second equation already has a negative 5, I want the other one to be a positive 5. Okay, so that's what I'm hoping for. So what I need to do is I need to come in here and I need to multiply the entire equation by some number to make this negative 1 into a positive 5. What multiplies by negative 1 to get you positive 5? Well, if I multiply by 5, 5 times negative 1 is actually negative 5, so that's not going to work. So what I'm going to do is multiply by a negative 5. If I multiply by a negative 5 to the whole equation, that gets me all the way to the other side, negative 15x. Negative times a negative is a positive 5y, is a negative 35. Then I'm going to write the second equation right underneath it because I want everything lined up. Notice that because we were very clever in the way we multiplied the first equation, now I've got the two canceled variables, the negative 5y and the positive 5y are equal, opposite, and lined up so that when I add the two equations together, I get negative 15x plus 10x gets me negative 5x. Positive 5y minus 5y add to 0. I'm the one that forced that to happen. Okay, equals negative 10, and now it's a simple solve. So the hard step is deciding what to multiply the green equation by to make it equal and opposite of the other equation. The rest is not too bad. We're going to divide by negative 5 to get us positive 2. So for that, I'm going to have a positive 2 here. And for x, now I'm going to plug it into one of the two equations. It doesn't really matter which equation. I'll do the first one, 3x minus y equals 7. But I know x is 2. So that's 6 minus y equals 7. Subtract 6 from both sides. And that leaves me with negative y equals 1, and divide both sides by negative 1 to get y equals negative 1. If you're interested in checking, you can check your work. 3 times 2 minus 1 times negative 1, that's what, 6 plus 1. Does that equal 7? Yes, it does, so the first one checks out. The next check is 10 times 2 minus 5 times negative 1, and that's supposed to equal 25. So we got 20 plus 5 equals 25. So that one also checks out. So I know my solution is 2, negative 1.